Every day we're flooded with numbers, sleep scores, blood sugar, step counts, macros. Some come from our doctors, some come from these wearables, and some from ads that say, science says you need to do this. And all of them come with a question. What should I actually be paying attention to? In this episode, we'll explore how to navigate health data without being overwhelmed, cynical, or even rigid. We'll talk about what makes a study trustworthy, how your beliefs can shape your biology, and how to make decisions that reflect your body, not just your biometrics. Because using data like a human means staying curious, not just compliant. So, Dr. Teplow, what does it mean to stay curious, not compliant, or not certain?
Well, I love that question. I think one of the hardest or most difficult issues when it comes to what do I do to maintain my health, extend my health span, is how do I make sense of the health data out there? Because we're inundated with it. You just can't you can't be awake and not be bombarded by health data. And so you also said compliant. How do we, as humans, that word compliance. And I said, oh, that's a really, that's kind of a red herring, is that when we read health data, it often is in absolutes. Science proves 100% this, I'm not even going down the magic cures, but just, science says it's absolute. And then when we say, how do we put this into practice in our own lives? We think, we have to do it all the time. And we kind of impose on ourselves rigid rules, as do some of these claims, never do this, always do that. And compliant means that you comply, you obey. And this was an issue in languaging, I don't know, maybe 20 years ago in medicine. Do we want patients compliant or do we want them to adhere? And so now the trend is to talk about adherence. Adherence means stick to, but it doesn't mean you're clicking your heels together and saluting on obeying. And I think that is really an important lesson to embrace, is that no matter what we read, and we'll talk about what makes reliable science, but no matter what plan it is or what idea we're considering embracing, it's not about obeying it absolutely without questioning. It's about adhering, sticking to some principles. It may be sticking to the practice, but it doesn't mean you have to be 100% perfect. It doesn't mean always, all the time, forever. We have to keep being curious and not certain.
And that's really how we're looking at it with the compliant means if I mess up, if I don't do this exact thing, then I wasn't successful at it, where the adherence is just more the direction that we need to be moving, because we know with behavior change that it's not a linear line from A to B to get to where we want to go. It's lots of fits and starts up and down. But as long as we're adhering, we're moving in that direction.
Right, exactly. It's what direction are we moving in? And it's looking at whatever we're doing in the context of our overall, our big lives. And that brings up an issue about how do we interpret scientific data? Because often maybe even much more than often, when you're testing an intervention, it has to be done on people in which the data won't be confounded. So if you're testing an intervention on, let's say, I don't know, healthy eating, then you want that intervention to be done on people for whom healthy eating will have an effect and who don't come with other conditions that might confound or mess up your healthy eating intervention. So let's say, I want to see about healthy eating's impact on sleep. Well, you would want to have people who had maybe on the optimum sleep practices. They're not working double shifts or graveyard shift, because we already know that sleep's going to mess up some things. That's one example of an intervention.
Well, let's talk about this question around what makes science backed. When we're trying to adhere to something that's what science says, what the research says, what is considered science backed versus, or not even versus, but versus clinically proven? We hear those terms thrown around, and so how do we know whether to follow this science backed approach?
That's a great question. So yeah, we'll see that all the time, science backed or clinically proven. And the question is very simple, is how many people were in the study? Too often you see studies that have 20 people or 30 people. Now we know that intervention may have worked wonderfully for 20 people or 30 people, but can we generalize those results to a whole population? And you're part of that bigger population. That's the first thing. The second thing, was it peer reviewed? Did it go through rigorous review? People looking at how a study was designed, the methods that were used, the results, the conclusions people came to, and the limitations of the study. So if you're looking at a study for an intervention of, eating an apple a day, how many people were in the study? Who was in the study? What were the demographics? Was it all 6-year-old kids who are healthy, or 55-year-old people with diabetes? Has the study been replicated by others? That's really important. You can have a study that delivers certain results, but you could never replicate it. So again, is it generalizable? Can we replicate it? That means the results are reliable. And a really big question is, who funded the study? We know, a bias sneaks in a billion different ways. Who funds a study often, almost automatically introduces bias. And what kind of study was it? Was it a randomized controlled trial where you have two arms? One doesn't get the intervention and one does. Was it observational? Everybody gets the intervention. We're observing what happens. There are many different kinds of study. Randomized clinical trials are considered the gold standard. And then we want to say, were the results statistically significant or clinically significant? So statistically significant means that it made a difference. But there's this great quote from Gertrude Stein, writer in the early 20th century, as I think it's something like, for a difference to make a difference, it has to make a difference. So we can say, it's statistically significant. But as for instance, if you have 1,000 people and this intervention drops the risk of bad stuff happening from 2% to 1%, that's awesome. That's a 50% reduction. But in that 1,000 people, if only 2 people actually get this disease, then what is the clinical significance? Does it make a difference to you? Well, in that case where I'm one of the 1,000 people and the risk is reduced by half, but only 2 people ever get the disease, does it really make a difference to me? So you have to understand what these data mean.
Yeah, the thing that you said that stuck out was the bias creeps in thousands of different ways. So that there really isn't a study that won't have some level of, maybe not bias might be too big of a term, but some level that says that this is not completely geared towards me.
Absolutely. You absolutely must look at that. In my past history developing continuing education for physicians, I remember we did a tremendous amount of work on hepatitis C. Now, interestingly, where hepatitis C really, it's called the silent disease because it doesn't manifest. It kills your liver. It doesn't manifest until you're in your later middle age or 60s and older. Interventions were tested on healthy adults in their, so you can say, these results are fantastic. Look what happened to these people. But usually the majority of patients didn't show up at doctors' offices in their 40s. They showed up in their 60s. So you would anticipate that things are going to be different for people in their 60s who are already developing chronic disease or come sicker, whatever. So you have to look at that population. Does this really represent me? And the other thing we know is science is always changing.
Yeah, that's something that I really thought was really interesting. Is that we see that all the time. It's like, okay, take this supplement; it'll solve your problem. And then later, this supplement is going to kill you. So stop taking that. And that comes up all the time. And like, well, now I don't know anything. I can't believe anything.
Yeah, that is a challenge. And I have a story about, scientists, I think, appreciate that science is always changing. And we think we know a lot. We do, but it's the tip of the iceberg for, for the world of knowledge. And here's one example. Everybody knows about ulcers, causes pain, right? So until the 20th century, people thought ulcers were raise your hand if you think ulcers are caused by stress, right? Of course, stress. What about spicy or acidic food? Raise your hand. Yes. What about smoking and alcohol? Yes. What about excess stomach acid? Raise your hand. Yes, of course it's caused by that. And that was the belief. So if you had pain, ulcers, painful, stomach pain, you had to eat bland food, lower your stress, etc. Okay, well, lowering your stress, that sounds good for everybody. But Australian doctors, Barry Marshall and Robin Warren, said, well, is this really so? They questioned it. And what they found is that a particular kind of ulcer is caused by bacteria. And it was a bacterial infection. It wasn't all the stress and the good, yummy food. And in fact, one of them inoculated himself with the bacteria and cured it instantly with a course of antibiotic therapy. So, and they presented their findings in I don't know, around 1980s, 1990s. They presented their findings and the gastroenterologist said, no, that's totally wrong. And they said, no, we know it's not. And they proved it. They won the Nobel Prize, I think in 2005 for their discovery of that. And that, how recent is that? We're not talking about using leeches to, suck our blood or whatever else they did in, centuries ago. We're talking about 25 years ago. So our understanding changes. So what do you do when you find, first of all, make sure that whatever you're following, whatever science you're following is as rigorous as possible. It's been tested on huge populations that look like you. It's been replicated. It's been done multiple times. You might look at the results of a meta-analysis. So a meta-analysis is taking all the studies that are looking at the question you're asking. It analyzes the rigor of those studies, the reliability of those studies, and then it draws a conclusion. So in a meta-analysis, it may look at 2,000 studies that looked at the same questions. And then when subjected to these questions about how rigorous is the study, how big was the population, can the results be replicated, et cetera, you may go from 2,000 studies to 10 to meet the criteria for solid, rigorous research. And then you draw those conclusions. So that's probably the most reliable if you can find results from meta-analyses, the multiple populations over time, replicated, etc. So that's one thing. And then ask yourself, does it make sense to me?
This really comes back to that over and over again is, we in our programs, you are your own lab, you are your own experiment. And it comes coming back to that, that we are an individual, and that doesn't, if the population is not what it looks like me and is not the same demographics as me, then obviously the study is not going to be as valuable. But even still, there is an individuality beyond that, and even if that population is pretty close. So you're never going to be 100% because we're all individuals, and especially in nutrition science, when we get the funding piece, the funding bias is huge in nutrition science. And then does it replicate the population for me? And then it changes over time. So we have all these different variables that say, I feel defeated now. Okay, so what should I do if I don't feel confident about which way to go? That's really a key question in all this is, which way do I go? What direction do I go? And we see people jump from one program to another program to another program, especially in their diets, maybe also in other exercise movements, and people are religious especially about their eating programs. They're religious about that. This is, I'm so certain this is the right direction that you should be going. You should be doing this program. This is this.
I love that. Yeah. And that's exactly what I was going to say is people make their regimens into a religion. Don't do it. It just won't help because change is happening all the time. And recognize that that you're changing all the time. I mean,
Uh,
think of yourself at your worst. Do you want to not change? Do you want not to have ever, do you want to have never changed? Oh no, we're always changing. And we often quote Ellen Langer from Harvard's psychology department, who developed a kind of a Western perspective on mindfulness, which is paying attention and just noticing. And she talks about stress and says that often we're consumed about stress because, especially with our health, because if we're certain and then it turns out we're wrong, we get hit over the head. Oh my God, we weren't right. Or if we're certain we're going to get ill, and this is, especially it comes with eating. Oh, if I eat this, it's going to, make me fall over dead or whatever, then that increases the symptoms, turns our attention to be looking for those symptoms. And then if we're uncertain and believe we should be uncertain, then if somebody asks, well, how long has this been going on? Or how do you know? Then we're even more stressed. So Langer says there's a fourth way to be, and that is to be confident and uncertain at the same time. And that's a kind of paradox. How can you be confident but uncertain? So she says when we're willing, when we know we don't have all the answers, but are willing to take action anyway, it's easier to act with confidence, because, so often if we're not certain, we just stay paralyzed, right? And so if we acknowledge that everything's uncertain and it becomes a part of everyday life, it doesn't stop us in our tracks. We just say, okay, we're going to look at the best, we're going to do our best, and we're going to keep noticing. Does it make a difference?
Does it make a difference? And I think that's something that's important that we emphasize in our programs as Tim in the Lab, and definitely what we're going to be emphasizing in our upcoming Healthy Eating Quest, which we'll put a link into the description here, is that everything is changing and you're noticing. It doesn't make a difference. And you're taking it from the religion of one way to go about things to because the science says right now that that's the case, to something one level higher, or a thinking that's more about what you value, that you do. And everyone who's doing this work does value their health. They're looking at the reason that they have this religious thinking about their diet or the way of doing it, because they do value their health. They are trying to find the best answer to the question. Thinking about it more about that you value your health, and you value your curiosity around this, I think gives you some of that flexibility in your thinking and how you go about this, looking at that you're changing and that the science is changing.
Yeah, absolutely. And Albert Einstein has a great quote, if I can find it in my notes, that the important thing is not to stop questioning. Curiosity has its own reason for existence. So, and attributed to Mark Twain is, it's not what we don't know that gets us into trouble. It's what we know for sure that just ain't so. So absolutely want to look for the best science, keeping in mind that we still don't know everything, and what's proven today may be disproven tomorrow. So don't go too crazy down any one extreme. I think it's don't make your diet or your whatever health regimen a religion. Be gentle with yourself, be comfortable with uncertainty, and confident. I'm doing what makes sense to me right now, and I'm keeping my mind open. And remember, from evolution, the only reason that we're all here today is that our ancestors from 200 years ago, 2,000 years ago, 20,000 years ago, 200,000 years ago adapted. So I think if there's anything that, we can say as a kind of a final point, is we're all here because our forebearers were adaptable. And so when you stay curious, you ask, does this make sense to me? And and what am I looking for in the answer? What's my own personal bias, and what's working? Do more of what's working.
That sounds like a fantastic place for us to wrap up. And if this was helpful, hit like or subscribe. It helps with the algorithm so we can share this with more people, because we talk about solution-focused strategies every week. And if you subscribe, you'll get a notification when we do. And we want you to be able to sign up for that Healthy Eating Quest, which is coming up. It's the Healthy Eating Quest: Fuel the Life You Want to Live, a science-backed, flexible way to eat, no shame, rigid rules, or deprivation. And if you want to learn more about our unique solution-focused approach, book a complimentary coaching session by visiting staminalab.io. All these links will be in the description, along with a link to Ellen Langer's book, which was Thinking Our Way to Chronic Health, which Dr. Teplow quoted. So also leave any questions in the comments below. We love to answer those. Thank you, Dr. Teplow.
Thank you.
Thank you, everyone, for listening. Until next time, remember, you are your own lab, you are your own experiment, and you are your own best coach. Be well.